Question 12. The diagram opposite shows the three complex numbers z, z squared, and z cubed. The modulus of z is greater than 1. This is the real axis. This is the imaginary axis. We have 1, 2, 3 complex numbers plotted on the Argand diagram. Part 1. Copy the diagram and label each of the points shown. Again, here's our real axis, here's our imaginary axis. Points are labelled opposite. This yellow point here is z, the blue point here is z squared, and the green one is z cubed. As the modulus of z is greater than 1, each successive power of z is further away from the origin, i.e. they are spiralling away from the origin. So we know that we always start on our positive side of our real axis and we rotate anti-clockwise about the origin. Since z on its own is z to the power of 1, this point here, this yellow point, must be z because it is the closest to the origin. We can draw in a line connecting each complex number to the origin if we want to physically measure the modulus. Now that our red lines have been drawn into our diagram, we can clearly see that the yellow point is the closest to the origin. So this must be z, which is z to the power of 1. This blue point here is the second furthest from the origin. So this must be z squared. And this green point here, which is on the real axis, is the third furthest from the origin. So this must be z cubed. And since this is z, when we are plotting z and we are looking for the argument, which is the angle that is made with the positive part of the real axis, we always start with the positive part of the real axis and move anti-clockwise. So this is the complex number z. Continuing on anti-clockwise, we get to the complex number z squared, and continuing anti-clockwise, we get to the complex number z cubed. So as you can see, the complex numbers are spiraling away from the origin. Part 2. Find theta, the argument of z. So again, we have our diagram drawn in. And this is the complex number z that we're interested in. And theta is the angle or the argument of the complex number that is made with the positive part of the real axis. So we're trying to figure out what this angle here is drawn in green. Remember again, we always move anti-clockwise about the origin. So we let z equal or kiss theta. Then z cubed will be or kiss theta to the power of 3. And here we apply de Moivre's theorem. So we're going to cube the or, and we're going to multiply theta by 3. So we cube the or, and we multiply theta by 3. So we end up with or cubed kiss 3 theta. So the reason that we decided to cube z is because of the three complex numbers drawn into our diagram, z, z squared, and z cubed. So z cubed is the only complex number that we actually know the angle of because it lies on the positive part of the real axis. This would have been rotated a full 360 degrees. So because z cubed lies on the positive part of the real axis, it was rotated anti-clockwise by 360 degrees. So if z cubed is equal to or cubed kiss 3 theta, well, we know that z cubed is actually 360 degrees. So we can let 3 theta equal to 360 degrees. We know that this angle here is equal to 360 degrees. There's been a full rotation of the Argand diagram. So 3 theta is equal to 360 degrees. And then solving for theta, dividing across by 3, theta is therefore equal to 120 degrees. So question 2 asked us to find theta, the argument of z, and we did theta, the argument of z, the angle is 120 degrees. Part 3. If the modulus of z cubed is equal to 9 over 4 multiplied by the modulus of z, express z in polar form. So another way to express the modulus of z cubed, so remember z cubed is this complex number that is on our real axis. Another way to express the modulus of that is to say the distance from the origin, and another way to say that is r, but in this case it would be r cubed. So we know that r represents the distance from a complex number to the origin, or else you could think of it that it is the radius of the unit circle. Now z cubed is not on the unit circle because it is further out along our real axis, so technically it's not actually a unit circle, but we do still use r. And this is because we're changing into polar form. So the modulus of z cubed can be rewritten as r cubed. And likewise, the modulus of z can be rewritten as r. So we've set up this equation. We have r cubed equals 9 over 4 r. So what we want to do is solve for r. So we can start by dividing across by r. So r cubed divided by r is r squared, and 9 over 4 r divided by r is 9 over 4. So what we did here was we just divided across by r. So we have r squared is equal to 9 over 4. So r is going to be equal to the square root of 9 over 4, which is 3 over 2. So now we have r to be equal to 3 over 2. So we're going to let z equal r kiss theta. So z will be equal to 3 over 2 kiss 120 degrees. So we're substituting 3 over 2 for r and 120 degrees for theta, which we got from part 2 on the previous slide. And then expanding this, we have z is equal to 3 over 2 cos 120 degrees plus I sine 120 degrees, which is in polar form.